Algebra has developed a lot in Middle East in the early centuries, and one of the famous mathematicians around that time period is Al-Khawarizmi, okay? And he actually divide the quadratic equations into three different cases. And around that time, all the questions tried to solving the practical cases, which means you need to pay a certain amount of money to buy a certain number of animals, whatever like that, right? So there is no situation like handling the negative numbers in it. So he separate the quadratic equation into three different cases, and for all of these, those question or constant term a and b's are always positive. Okay? So in this case, a is positive, b is positive, and this one, this case, same thing, a is positive, b is positive, like that. Okay? So when you think the solving quadratic equation in our own way, you know how easy that is, right, compared to this. So around that time period, they didn't have the quadratic formula. So they have to think all different cases, and for them, these cases are all different ones, right? But still, they are clever enough to find certain method to solve each one of them. So in this chapter, we are going to just dealing with one of such cases. The first one is when they try to calculate certain things, they always come up with some geometric kind of models and explanation about it, and it really helps them to understand the situation. So their method was like this. When they need to solve x cubed plus 12x equals 189 case, they just imagine there's a certain number that we are looking for, which is x. So x squared means the area of this square. Okay, good. And they want to arrange this 12x around it. So we already know the x, okay? Then 12x means around x, they could put four same shapes around it. So the side of one of these is x. Then how much do we need to take care of this 12x? We have four pieces. So which means divide this 12 by 4, the remaining is 3, then this should be 3, right? For each. 3, 3, 3. So those area of this shape is exactly same as this left hand side, x cubed plus 12x, right? So just take the divide this 12 by 4 and arrange like this. Then this area must be 189. And that was the difficulty like to solve it, because it's a little bit it's difficult to do that. But let's just fill out those four corners, because in that case we know the numbers for that. It's 3 by 3. So we're just adding 4 3 by 3, right? Which is total 36. So from given equation that x squared plus 12x equals 189, if we adding up this 36, then on the left hand side, that's the area of this, including that 36 over there. Then when you add 36 on the right hand side, the total is 225, yeah, like a 225, right? Like that. So what is the area of this entire one? The length of each side is x plus 6, right? 3 and 3, so x plus 6 and x plus 6. So x plus 6 squared becomes 225. And 225 is actually 15 squared. So I have to cancel out this. X plus 6 equals 15. So x must be 9. And that's how they calculate to get the answer for that. Okay, so let's do the let's just apply same method here and to calculate, to find the x values. Right now, so it's only working for that kind of format, right? X squared plus 10x. So we have is x squared, and divide this one by 4, which gives us x times 10 quarters, which is 5 halves, right? For the side. So this area must be 39. Then we won't include this 4 extra square, right? So each square looks like 5 halves or 10 quarters, right? So 5 halves. So that is 25 square over 2 square, or 25 square over 4, right? But we have 4 of them, right? 4 pieces of this. So the entire square must be 39 plus 25 square over, or 25 is already square, right? So 25. So it's a 25 over 4 and 4 of them, right? So it's going to be 39 plus 25, which is 64, and that is 8 squared. And this one is actually x plus, now be careful, that is 5 halves, and we have another 5 halves, so total is just 5, right? So the entire area is x plus 5 squared. So when we look at those two, we found that x must be 3. Next famous mathematician is Abu Kamil. And he actually got the information from Khwarizm's literature like that. So he just developed a certain method in here, and sometimes he just add his own method, okay? And a lot of times it's kind of better and faster method. Okay? Okay, now, so the following one is one of his such extension of our Khwarizm's work. Okay? And the method is like this. The given question is x plus y equals 10, and x over y plus y over x equals 4 and 1/4. So from this equation, x over y plus y over x, and when you try to get the common denominator by cross multiplication, we have x squared plus y squared, and that is 4 1/4 like that. Then from there we know that x squared plus y squared equals, when you multiply xy on both sides, we have 4 1/4 xy, or 4 4 16, so 17/4 xy if you want. Now this is his technique out of nowhere. Looks like he just assigned new variable z and saying x equals 5 minus g and y equals 5 plus g. It actually came from this given condition, right? So x plus y equals 10. We don't know what exact value for x and y is, right? But we know when you add them, it's going to be 10. So, okay, the median of xy must be 5, right? So if maybe both of them are 5, or if one of them is less than 5, then the other one must be greater than 5 with the exact same amount. So let's say x is 5 minus certain number, certain value, but we have to make x plus y equals 10, then y must be 5 plus that same amount, right? That's how this idea came from. Okay? So if it's something else other than 10, then you have to change the number by that, right? But the method is same. So half of this given constant term is going to be the ones you need. and minus c plus c. That's the typical style. Okay? Then we just substitute this one into this expression. Okay, so x squared is 5 minus z squared plus y squared is 5 plus z squared equals like a 17 quarter times x times y. Now in algebra we know these identities a squared minus b squared. Right? So x times y means a minus b times a plus b. So it's going to be a squared minus b squared together. That's how we got this one. So let's just simplify that. That's a 25 minus 10z plus z squared plus 25 plus 10z plus z squared. Right? On the left hand side. On the right hand side is just 17 quarter 5 squared minus z squared. So these 10z's are cancelling out each other. We have 50 plus 2z squared equals 17 quarter 5 squared minus z squared. So let's just arrange it like a multiplying 4 on both sides. So 200 plus 8z squared equals 17 times 5 squared minus 17z squared, right? So you can move this one like that and subtracting like this. So we have 25z squared equals certain number, but eventually we are going to get z squared equals 9. Then z must be, technically it should be plus minus 3, but when we think this idea, we kind of adding and subtracting same amount. It could be positive, negative, doesn't matter, right? Because we got just sharing that values. So we only think positive numbers in this case. Therefore, if you look at that equation with that condition, then you know that x must be 5 minus 3 is 2 and y equals 8. And it's the answer to satisfying that system of equations. Now, the Camille actually developed some other formulas, many of them, but another famous one is he developed certain method to calculate the subtraction between those kind of irrational numbers, right? Square root of that. And it has some explanation like this in his book, but let me just change this one in our own word. So, and using some equations, his methods like this, to get the difference between two square root numbers, let's start with square of those numbers and subtract to ab. Then that is same as a minus b squared. It's known. And then from there, let's change that ab to square root of a squared form. Okay, so instead of a, we put square root of a, right? So this is kind of formula. So instead of a, you're using square root of a, right? Then square root of b, then minus 2 square root of a square root of b equals square root of a minus square root of b squared, right? So I'm not saying a equals square root of a, right? It's just totally different. This is just general, the identity in algebra. So just to substitute square root of a for a and square root of b for b, right? Then we got that one. Then when you pull out, the first term is a, second one is b, and we have 2 square root of ab. And that is square root of a minus square root of b squared. Then in algebra, we also have something square equals something like that. Then that square is actually plus minus square root of triangle, right? We have that kind of ones. So once again, it should be plus minus, but what in that time period, they just took kind of interesting about solving some real world situation, right? So numbers should be positive. So we only accept positive number. So let's treat this is that square part, right? Something squared. So we are looking for what is that something, right? Only. So removing that power 2, which means we need to put plus minus square root of these numbers, right? But we only accept positives, right? So that's how we got this formula. So without knowing what is the square root of 9 and square root of 4, by this method, which we can actually calculate. Okay, so let's look at more realistic case. Okay. Use the Connell's method to calculate the square root of 98 minus square root of 32. So without actually finding that notation for square root of 98 or something like that, right? So according to his formula, square root of a minus square root of b is square root of a plus b minus 2 square root of ab, right? So 98 times 32. Then when you pull out, let me calculate it. 98 plus 32 is 130. Okay? And 98 times 32 is 3136. Okay? Check. And 3136 is 56 squared. So it's going to be 130 minus 2 times 56, right? So altogether is 130 minus 112, which is 18, so which is 3 times square root of 2.